So you guys, we talked a good deal about Cramer's rule, and there was assignment 2.3, and matrix equations, that was assignment 2.4. I reckon I want to start with 2.4 and we can kind of work our way back. But one of the things that you really, really need to have locked in is how to find the inverse of a matrix. Okay. Now, what I mean by that is in this scenario, like this example, there's an unknown matrix that I'm trying to figure out. I don't know what matrix X is. Okay. But I bet you guys could tell me what his dimensions will need to be, right? Because this one is a 2 by 2. So as far as his dimensions go, what do you know the number of columns is going to be? How'd you know that, Will J? Good. The inner two have to match. And then what do we know that the dimensions of our answer are going to be? Well, just look at our answer. And it's 2 by 2. So guess what that makes this? Yeah. So this is a scenario where we've got a 2 by 2 times a 2 by 2. Okay. So I know that my unknown, I know mentally like what it's going to look like. That's an unknown matrix. And the way that I'm going to get it by itself is I'm going to actually pretend like these matrices have some names. So my unknown matrix we'll call X. Let's just call this guy A, and let's call this guy B. All right. Now you ought to be comfortable finding the inverse by hand, Grant, and on the what? On the calculator. Very good. So if I can find it by hand, and if I can find it on the calculator, man, I'm set up for success. All right. So check this. Let's find it by hand first, because what we're going to do is we're going to multiply A inverse, whatever it is, times both sides, because these two will cancel down, Mr. Kelly, Mr. Brody Kelly, to what? What will A times A inverse cancel down to? Very good. We call that the identity. We call that our identity matrix. And so that's very nice. That's like saying this matrix times 1 or just plain old this matrix. So that's how we're going to isolate what we're trying to solve. X is going to equal B times A inverse. Now, hopefully you can see where I'm going with this, because if I know that X is B times A inverse, why don't I just store this is A, this is B, and then type that into my calculator? That's the fastest way to do it. But just to make sure we know how to do it by hand, let's practice doing it by hand. Zach, was that a raised hand? Okay, gotcha. All right. So we're going to call A, this is A right here. Let's go ahead and find A inverse. Kind of do this on the side. Do we remember it involves 1 over the determinant of A? Yep. So 1 over. Now, I ought to be good at calculating determinants at this point. So this looks like negative 104 and then minus 7. So what is that, negative 111? Because I'm an idiot. How is 8 times 13 negative 104? Good. Y'all ever have brain farts? I have them all the time. So just work with me. Good job, Grant. So there we go. And then now, how about what do I do with these? This bottom, or excuse me, this down into the right diagonal. What do I do with the negative 8 and the 13? All right. So we're going to have a negative 7, and then 0 just stays as 0. Okay, so that's my A inverse. There we go. There's A inverse. I tell you what, let's do this. Let's move and down. Bless you. Now, truth be told, do I really want to distribute that scalar, that 104? You got to distribute that. That's crazy. All right, but now that I know what it is, I come over here and I can say, all right, well, look here. X now is going to equal 96, 104, negative 60, 52 times negative 1 over 104. I like my negatives up top. 13, 0, negative 7, negative 8. All right, and I can multiply those two. Now, I do not like the idea of multiplying this times these 4 and getting 4 fractions and then doing a matrix multiplication. I prefer doing the matrix multiplication first and then tacking on that scalar. However, I'm not 100% on it just yet. I need to go back and look at my notes as to, we know like matrix multiplication is not commutative, but I do believe scalar multiplication is. I'm not 100% on that. So just, don't hold me to that just yet. But do you understand how we've got it set up now? This was B, this was A inverse. And the reason A inverse was on the right was so it could be right next to A, cancel out, and therefore it needs to be on the right over here. At this point, I want to plug them in on my calculator. And I'll tell you what, let's do, I don't know if y'all like doing them on the home screen. I like storing them. That's my usual way of doing it. So like I'm going to go second matrix. Matrix A is a 2 by 2. And I'm just going to store that. -8, 0, 7, 13. And by the way, it doesn't hurt at all to just do a real quick visual check. Make sure you got it typed in right. 3 times this morning during second period, I had some typos because my keyboard, I was typing too fast and it wouldn't log in the keystrokes. No, actually, I'm not. Great question. I'm actually going to just type it in as this, and then I'm going to show you on the calculator how to check your inverse. You know what I mean? So there it is. It's typed in. Now I'm going to call it up, matrix A. There's matrix A. Hello. And then I'm going to call up matrix A now. And what I want to do is hit the little caret and the -1. We're not raising it to the negative first power. We're using that as a notation for inverse. Now, can you go ahead and before I hit enter, describe for me what you think that resulting 2 by 2 matrix is going to look like. Is it going to be very pretty? Why not, Linda? Yeah, I'm right. It's kind of a buttload of fractions. So before I hit enter, I should hit math, enter, enter. And that turns all my little dudes into fractions. Great. Hit caret, -1. This button right here. Have y'all verified that works? Okay. Caret is over here above the divide by sign, and it's how you raise something to an exponent. I didn't know 100% sure if that was working. So you like that? That does it for us? Nice. Grant, did you type yours in correctly? Go back and double check. -8, 0, 7, 13. Did you use a -8 or a -8? All right, I'll come back and troubleshoot.
You don't get the fraction of a negative one. But like the fractions of a negative one.
Oh, snap. I wonder if you did that. Let's see here.
Sure.
-8, 0, 7, 13. Now, it might be that you're using this older calculator too.
Yeah, so I think it's very good.
All right, well, let's do this then. Let's go matrix A. Just inverse. Yeah. Okay, so just use that button right there. So raise it. First power. Don't go up there. Matrix A, and hit that button right there. Let's say big one. All right, so hey, y'all taught me something today, y'all. On those older calculators, raising it to the caret right here doesn't work. So this button right here, this -1, would be superior if you got an 83 plus or one of those other calculators. All right, but we're comfortable finding the inverse by hand and on the calculator now? Okay, so let's put that in action. Which way should I multiply? Should I multiply before B or after B? We will multiply it after B. Here's our inverse. So let's plug in B into our calculator. All right, so go to the matrix menu, edit matrix B, 2 by 2, 96, 104, -60, and 52. Now on the home screen, here's what we're going to type. We're going to go matrix B times matrix A inverse. And then just for dexterity's sake, we'll hit math, enter, enter. Probably don't have to. And certainly we didn't. It's -5, 8, 11, and 4. Does that help? Okay, well, remember how we said X was a 2 by 2? Right, so this unknown 2 by 2, there you go. Now, what's nifty about this is that you could check your work. Watch this. I'm going to store that answer as matrix C. I'm going to store that answer as matrix C. The store button is above on. It's STO with an arrow. Okay. Now, based on what we just figured out, I should be able to say C times A and have it equal B. Let's test that out. C times A. And looky, that wound up equaling B. So that looks good. So we can kind of self-check there. Everybody comfy? The answer we got for X, I don't like storing a matrix for X. That tends to mess things up sometimes. So I just stored it for C. I called this unknown C, and we did C times A equals B, and it checked out.
Wait, so wait, after you put in matrix B, what do you do?
We did B times A inverse. B times A inverse. And that was our answer for X. I called it C just to not confuse the calculator, because sometimes when you store something for X, it'll get a little wonky. Mr. Higginbotham taught me that. Now, on Delta Math, again, kind of looking at 2.4. Okay. Here's a question where it just says, hey, what's the inverse? Now, I want you to be able to do it by hand, and I want you to do it on the calculator. So just a little bit of both. Practicing a little bit of both of those. Let's check. What's the determinant first? We got 14. Take away 14. So the determinant equals 0. So this is, what do you call that? Singular. Yeah, very good. That matrix does not have an inverse because the determinant equals 0. That's a special case. You're going to see a whole buttload of those? Everybody say no.
No.
You ain't going to see a whole bunch of those. All right. So I don't know whose that one was. Shane, that was yours. Let's see if Mr. Potter. Okay, good. So like Mr. Potter, we got negative 15 minus negative 8 is plus positive 8. So it looks like negative 7. So we're going to have a negative 1/7 out front. And then these two are going to change positionally. So negative 5/7. Negative 5/7. And then negative times negative is positive. So we have 3/7, the bottom right. And then these two, we're going to change the sign. So we got negative 1. Now, negative 1 times negative 1/7 will be 1/7. And then this one becomes positive 8. Now, what's 8 times negative 1/7? Negative 8/7. And we check answer. And they say, good job, Coach Morgan. You did a fantastic job. And they walk you through the process. I did that one in my head. I'm not recommending that. In fact, I would write it down, like step by step. These two guys switch, these signs. Here's 1 over the determinant. What if the determinant's 0 again? Singular matrix, not inverted. All right. So finding the inverse is good. Y'all know how to do it on the calculator now. Let's look at some of these questions that were in the middle here. Who's this? Will Plummer, we'll look at yours. So the hard part, I think, about these is going from the system. There's my snipping tool. There we go. Going from the system and actually solving it out. This is not using Cramer's rule. That's what 2.3 was about. This is just turning it from this is turning it from a 2x2 system into a matrix equation. All right, so we're going to have A times X equals B, right? What's my A? My A is just a snapshot of that left-hand side. 3, negative 3, 1, 2. X is just XY, and B is just negative 7, 5. I'm going to make sure they understand how that works. Okay. So that, I feel like that's the hard part. And then once you see that, you're gravy. You're like, oh, put the inverse here on the left, put the inverse here on the left. Inverse of what? Inverse of A, right? And that's where we would say there's A inverse, there's A inverse. Those two cancel out, and we're just left with that right there. Okay. Now, finding the inverse by hand, they're checking to see, does he know how to do that? We definitely should. Sam, what's this fraction going to be up front? Very good. What kind of fraction though? Very nice. So what he did was he did 3 times 2 is 6. 1 times -3 is -3. 6 minus -3 is plus +3. 6 plus 3 is 9. So we got 1/9. We're going to type that in at the beginning there. We say 1/9. And then those two there and there, they swap spots. These two change what? All right. So we've got our inverse. Now we just got to say, well, let's multiply it. Mm-hmm. I think I had screwed it up initially because I was thinking and not writing, or writing and thinking at the same time. This should be 2, 3. It should be -1, +3, and it was 1/9. Is that right, Tim? All right. Now, let me ask you fellows this. Which one should I multiply first? Should I multiply scalar or should I multiply matrices? Matrices first. Why? You don't want a buttload of fractions. 1/9 times these three guys is going to create 4 fractions. That's going to make my multiplication more difficult. So let's see here. We're going to have row 1, column 1. So that's row 1, column 1, and then we'll multiply by 1/9. So let's see here. Row 1, column 1. We got 2 times -7 is -14. 3 times 5 is 15. So that's 1. 1 times 1/9 is 1/9. And then we'll do row 2, column 2. All right, so let's see here. That's 7 and 15. That's 22. Very good. 22/9. Now, Grant, I'm curious, calculator or... And so you guys, my point being, you guys can get pretty daggone quick at the calculator, can't you? All right, and it depends on whether or not you practice using it enough. So for my money, I would store this as A, store this as B, and then do A inverse B on the calculator, and you get your answer lickety split, right? 1/9, 22/9. 1/9. 22/9, and then they walk you through that process. Ben? Sir? Yeah. It's not a bad question. All right. So let's do, actually, I'm going to forget who it was I was talking to earlier, but he said he preferred like doing it on the home screen. He did not like to store it. And so I'll show you how that works. So we're going to call up a 2 by 2. This is going to be my A inverse. What I'm going to do is I'm going to type in A, which is 3, -3, 1 and 2. Then I'm going to hit my inverse button. And then I'm going to hit my times. And then what's B? Is a 2 by 1. Right? Yes. And so we'll do, what is it, -7.5? Now I've got some ugly numbers. Math enter. And there we go. And you can get very proficient at working that way. Ben, does that help? Do y'all prefer doing it on the home screen as opposed to storing it? Okay, so like whatever floats your boat, I care not. It matters not to me. You're not hurting my feelings at all. I was always a store it guy. And now that there's functionality with that Alpha F3, that shortcut, you can do it on the home screen if you like to. Okay. So let's talk about Cramer's rule. Cramer's rule can be a bit of a bear. Do we remember what Cramer's rule talks about? Ryan? Yeah, and more specifically, we're operating on those matrices to take the determinants. And in this case, this is a big old fat daddy 3 by 3 system. So there's going to be how many determinants? 3. It'll be 4. One of them will be our determinant of coefficients. And then the other three will be like determinant of X, determinant of Y, determinant of Z, or whatever letters they give you. I think in the video I did RST. Did y'all watch my video, by the way? Kinda. Yes, maybe no. All right. So in this case, I am not all about that. Do the determinants by hand. When they're 3x3s, use a calculator for Pete's sake. But we want to know what those determinants will look like. So check this out. Here we go. So the determinant of coefficients is just a snapshot of that left-hand side. So we got 2, 1, 3, -8, 9, -4. Ryan, was that a hand up I saw?
Yeah.
What you got?
Do we find the determinant with the calculator, or is that not?
Oh, man. Yeah, please do it on the calculator. Do you know the syntax, or do you want me to show you? Right. So like, I'll go ahead and check the determinant of coefficients, right? Because what if it equals 0? That's going to be one of those. Chase is going to tell us one of those two special cases. What are those special cases? Beautiful. Right. So like if all four of these equaled 0, it'd be infinitely many solutions, dependent system, throw on the brakes, don't do anything else. If the determinant of coefficients equaled 0, but the other three did not, then it would be no solution. Inconsistent system, we'd have where there's no way of solving that system out. Let's see here. Shane, how do I go about finding determinant of X? What do I do for X? It's a little bit different. Beautiful. And then everything else stays the same. So 1, 9, -10, 3, -4, 4. And when we plug that in on the calculator, we divide dx over d, and we get what the x value is. That's what Cramer's rule says. Right? So here's my calculator. I'll slide it over to the left. And let's do, I'll go y'all's route. I'll go the 3x3 on the home screen. Gotta scroll down here. Okay. What do I need to do before that, though?
Determinant.
Yeah, so I'm going to insert determinant. That's from the math tab. There we go. And look, instead of clicking right a million times, just hit second and to the right, and that jumps to the end. On your keyboard, like if you're typing, drop my new stylus. There we go. Ouch. On your keyboard, the end button right here, how that takes you to the end of the line if you're typing a Word doc or whatever, or home takes you to the beginning of that line. Are y'all familiar with those two buttons? Okay. I use them all the daggum time. If I'm typing something in a Word doc, like a paper or whatever, and I want to go to the beginning of the line, I hit home. And it's just a pinky tab up. So that's sort of like on the calculator. If you wanted to go to the very beginning, just hit second left, and that takes you to the very beginning. You would laugh. It's just the face you make. All right. Suppose that you wanted to, if I hadn't put DET in there and I overwrote it, what do I mean by overwriting? Okay, so look, suppose that I forgot this is Cramer's rule and that involves matrices. And I go back to the beginning and I'm like, I'm going to put the determinant there. Watch what happens. You go to the matrix menu, hit DET, and all of a sudden you overwrote, right? So instead of overwriting it, if you forget something in your line of code, if you're going through and you got your 3x3 and you're like, oh, shucks, I forgot to put the determinant, especially if you've already entered all that jazz in there. Okay, let's go ahead and enter it in and we'll play dumb. We'll be like, oh, nothing's wrong here. -4, 10, -10, and 4. Oh, for crying out loud, I forgot to put determinant on there. Robble. Am I going to want to overwrite that whole arrangement? Heck no. So I'm going to hit the second left. That takes me all the way to the beginning. Second delete. That is now where the cursor, instead of blinking black, it's blinking white. That means I'm going to insert. And so now I could go to my matrix tab, scroll to the right one, and insert DET. Now I want to get back to the end, so I just hit second right and close parentheses. Actually, you know what? I did the determinant of coefficients. Where should that be? It should be determinant of coefficients should be the denominator per whose rule? Cramer's rule, right? What do we want to insert before this? we want to insert the determinant of x. I'm going to insert my 3 by 3. Now this time I'm going to be doing the determinant of x. So there's negative 1, 1, 3. Y'all see that? Look at what happened. That's why we double check things as we're typing. Negative 1, 1, 3, negative 5, 9, negative 4, 7, 10, 4. All right, now check that out. I need to insert a parentheses and a divide by symbol to where now I've done the determinant of x over the determinant of coefficients, and I hit enter. What should I have hit? Math, enter, enter, and I get 43 over 46. So whoever's example I had pulled up from second period, once they entered in their 4 determinants and they hit try, it followed up with, okay, now what is x, what is y, what is z? What did I just solve for here? I just solved for x. Very good, because we did dx over d. Now, what's nice about the calculator at this point is that I don't have to type all that jibber jabber again. I can just scroll up and look, I don't have to mess with the determinant of coefficients. Why am I hitting left a million times? So what should I hit? Second left, right? And now I can just go through and I can change, instead of changing the whole arrangement for dy, I'm gonna insert the first row or first column is 2, negative 8, 10, and then the second column is going to be my constants that we were using. All right, is this tracking with you guys? Negative 1, negative 5, 7. There's my constants. And what is this going to be? 2, negative 8, and 10? 2, negative 8, 10. What should I have hit? Math, enter, enter. And there's my y value. And then similarly, we'll save a little class time. I'll let you guys do the last one if you wanted to for this particular example. But there you go. So applying Cramer's rule with determinant of x over the determinant of coefficients, determinant of y over determinant of coefficients. Is it a short process? Somebody in the earlier class said, "Dadgum, coach, I would much as soon rather do substitution or elimination." And I'm like, for real? Yes, absolutely. I get that. But this is Cramer's rule in a nutshell. Okay. Now, let's take a peek at what we're lacking in. Looks like most everybody, very good. Everybody got that first set. Second set, maybe a handful of folks. Third set, maybe a little bit more, handful of folks. Okay, so is this something that's doable by maybe tomorrow morning? I'm not hearing a whole bunch of yeses. Doable by tomorrow. Look at 2.3. All right, and 2.3 looks pretty decent. So if you didn't quite finish, so Will and Shane, I'm assuming it was the 3 by 3s that were just kind of dragging your feet with or whatever. And you can get those done. I honestly okay, so let's look at plumbers. Okay. You know what I'm gonna do is I'm gonna type in my determinants that I get from my calculator. As I got 4 determinants to calculate. And then once I hit that try button, okay, there are my 4 determinants. 1, 2, 3, 4. I get these from the calculator. I love their explanation, by the way. See how it's color coded? Where they've inserted the constants each time. So there's your 1, 2, 3, 4. And then from that, instead of doing a bunch of division using the determinants, I just jot those numbers down and you tell me, okay, so plumbers, very quickly writing down these determinants. You tell me, what's x going to be, Will? Cramer's rule is dx over d, dy over d, and dz over d.
So H would be 30.
Also known as You think 36, you think 36 divided, good rule of thumb. Whatever Grant says out loud, don't repeat it. That's a good rule of thumb, okay? What's 36 over 18? 36 divided by 18. It is just 2. So 36 over negative 18 would be negative 2. Good. Same thing here, 36 over negative 18. What about negative 18 over negative 18? Yeah, just 1. And so when they see these answers, that's where you've got your -2, -2, and +1. All right. There we go. Very nice. I think Delta Math wanted it simplified. I don't know. Well, let's see. Negative 18, 36, 36, 18. All right, hold on. Negative 18, we're investigating. 36, 36, 18. Was this one negative 18? All right, it's happy with that. And then what'd you say? Negative 6 over 3. And this one was, we'll just call this, we'll simplify this one as -2. And then this one was 1. Let's see if it counts it wrong. Womp womp. Yeah. So definitely want to, your answer is not simplified. That's all right. All right, y'all feeling okay with this? Yes? No? Maybe? All right, get out a half sheet of paper and clear your desk. No calculators. No calculators. However, I will say this. There's not going to be, I'm not going to ask you to do a bunch of fancy 3x3 work. All 2x2s. Is that a new one?
Yeah,
I like the color. That's a good looking color.
I got it.